Hello, AAT. We are in section 3.7, solving polynomial inequalities, and this is our last section for unit 3. So when you have inequalities, remember we're talking about greater than or less than. We're going to first make sure that it is where it has the polynomial on one side and it's either greater than or less than 0. And when something is greater than 0, that means it's positive, which of course is above the x-axis for positive y values and below the x-axis for negative y values. So to solve these, we're going to factor them or find the zeros, the roots, the x-intercepts. And between any two consecutive zeros, the polynomial is either going to be positive, which means it's above the x-axis, making it true if it's greater than 0, or negative below the x-axis, making it true if it's a less than 0 problem. So all we need to do is factor it first. Here it's already factored. Actually, first thing we need to do is get it equal to 0 or greater than 0, less than 0. Factor it, and then find those zeros or roots, which here are -4, +2, and +7. And then we're going to put those roots on a number line so we can think about where it's 0. Because here, if I plug in -4, this is all 0. And things change from positive and negative around 0. Here, if I plug in 2, this is all 0. So if I plug in a number somewhere, I usually like to plug in 0. So find out where 0 would be. 0 would be right here between -4 and 2, of course. If I plug in 0 to this, I get a positive, because I get +4 times a negative -2, and a negative, which a positive times a negative is a positive. So every number that I plugged in between -4 and +2 would give me a positive answer. And since when you go across a 0, signs change, and these are odd roots, meaning it crosses the x-axis, it's always going to alternate. So if this was positive, it's going negative, positive, negative, positive. So then I think of what I want. Well, I want only the parts that are positive, greater than 0. So I want this area and this area. Also, it is not equal to, so I need to make sure these are open circles. Not equal to. So my answer in interval notation is open from 4 to 2, meaning everything to 4 to 2, not including, union, open from 7 to infinity. Goes on and on and on. Open. Okay, we can always plug in numbers. If I plug in, that should be a -4, sorry. If I plug in 0, I can see that I'd get a positive, so that would be true. If I plug in 10, I can see that would be positive, so it would be true in that interval. So I can always check a couple numbers in the interval. Now notice this one has a multiplicity of 2. It occurs twice. That's important. That's an even multiplicity, twice. So if I put these roots on a number line, okay, what are my roots? My roots are +5, which occurs twice, +1, and -3. Okay, make sure they're in order. Everything's going to mess up if you don't put them on in the right order on the number line. This time this is equal to, so I'm going to go ahead and make these solid dots. This was not equal to, so they were open. And then I'm going to put a little star here on 5 because I need to remember that that's even multiplicity. If something's even, it bounced off the x-axis. It stayed negative or stayed positive. So on either side of this, we are not going to alternate like we did here. So plug in some number. I like to plug in 0, and 0 is right in here. I plug in 0, I'm going to get a positive because I get -5 times -5. I'm going to get a positive times a negative times a positive, which is a negative. So I get a negative there. It's going to alternate, Except for if I have an even root, it does not alternate around an even root. And what if I'm not sure? Well, let me just plug in some numbers and check. If I plug in 10, I'm getting a positive times a negative times a positive. Uh-oh, did I mess up? If I plug in 10, I definitely get a positive there. If I, that would be positive. So I get a positive, positive, positive. So yes, it'd be positive. If I plug in, say 4, I get a positive, positive, positive. So yes, that should be positive. So you can always plug in and check. I wanted the negatives this time. Okay, so my answer should be only the solid dots and the negatives. So it's negative infinity. So, no, it's not. It is this area, which would be negative 3 to 1. And those are closed this time. So the brackets like this would be inclusive, including negative 1, negative 3, and positive 1. Now, what about 5? If I plug in 5, will it work? If I plug in 5, I'm going to get 0 times 4 times 2. And 0 times anything is 0. And this is less than or equal to 0. So I need to also include 5. So I'm going to put a union. And when you put those curly brackets, those are single values. I want to also include 5. So be careful. If it's a solid dot, you need to include it. Okay, how about this craziness? Now, notice this right here is a factor. Move it up so we can see. But it is always positive because it's a quadratic factor. There's no way that that's not going to be negative. This is a root of negative 5. It's a multiplicity of 3. But it's an odd multiplicity, so it does alternate around that one. This one's root, ooh, that's a tricky one. So what's your root there? If you set 4 minus 2x equal to 0, we could add the 2x to both sides. 4 equals 2x, and x would be 2. So this is just the root x equals 2, and it still has a multiplicity that's odd. It only occurs once. What is this root? This root's just x equals 0, but it has an even multiplicity. Multiplicity of 2, that's even. So it's going to not alternate around 2. And this root is 6. This is about as crazy as you can get with an odd multiplicity. So we need to put all those things on a number line. Now this one is not a real number, a real root. If you set x squared plus 2 equal to 0, you're going to get an imaginary root. So don't put imaginary numbers on a number line. It's not there, it's imaginary. So we want to write that not on number line. So we just ignore it as far as the number line is concerned. It's always positive. It's not going to change. It's not going to affect the sign of everything else. So here we're going to, let's put negative 3. That's a negative 5. So negative 5 is my lowest value. Let's see, we got an x equals 0, so we got to have a 0 on there. We have a 2 and a 6. And how spread they are doesn't matter so much as long as they are in correct numerical order. Okay, so let's think about this. First of all, this is equal to, so these are all need to be solid dots. They are included in the final solution, needs to include all of these values. 0 is even, so I'll put a little star. That means it's not going to alternate around that. And this one occurs 3 times, but it's odd, so it's still going to alternate. And yeah, I think that's about it. So this time I'm not going to plug in 0 because 0 is one of our roots. So I'm going to plug in something else. Let's plug in something big, like maybe we'll plug in 10. And I can see real quick, if I plug in 10, I'm going to get a positive times a 4 minus 20 would be a negative, times a positive, times a positive. So that would be a negative up here if I plugged in 10. Okay, it should alternate, but I can plug in like 5 or something, check. Should alternate. Here, it does not alternate around 0 because 0 has an even multiplicity. But I could plug in 1 and see that's a positive, positive, negative, positive, negative. Is that right? Positive, positive, negative. Oh, no, that would be positive. So yes, it would be negative. And I could plug in like -1 and check it too. It would be a negative on either side. And it will alternate around 5. So positive, negative, doesn't alternate, negative, positive, negative. But always plug in numbers to check if you want to. So what are we looking for? We are looking for negative values or 0. So we got this area and this area and all the way through to this area. So we have our answer would be -5 to, I can go all the way to 2 because 0 is included also, so that whole interval, and they're both closed. And I'm going to do a union with 6 all the way up to infinity. Okay, flip it on over for number 4, find the solution. Now do know if you have one like this, -2 is not, does not have an x, so it affects how the signs change, but it's not a root. So it doesn't go on the x-intercept, on the number line as an x-intercept. So think about that. Remember, when you plug back in, it will make a difference, but it's not one of our roots. Our roots are all a multiplicity of 1. We have -4 from this, we have -1 from this, and we have 2 from this. If we plug in a nice easy number like 0 or something huge, if I plug in 0, I'm getting a negative times a positive times a positive times a negative. Plug it in and make sure, and a negative would be a positive in this area. So this is alternating because everything has a multiplicity that's odd. This is not equal to 0, so these are all open, which means we're going to use those parentheses. So we want positive answers this time. So positives, positives. So we're doing -infinity to -4, open, union, open, -1 to 2. All right. Number 5. So number 5 and 6 and 7 are not factored yet. So you got to start out by factoring them first. Find the roots, put them on the number line, and then find your solution. Here we're looking for negatives, and here we're looking for negatives or zeros. So this one will be closed and this one will be open. So go ahead, I will tell you this one does work by factor by grouping. It looks like they both do, or you could use your possible rational roots. So I'm going to pause. Okay, and here are those last couple. This one, like I said, does work with factor by grouping. Your roots end up being -3, 3, and 1. Put them on a number line. They're open because it's not equal to. If I plug in 0, which is in this area, and I plug it in the factored form, it's so much easier. I'm going to get a positive times a negative, which is a positive. Everything alternates because they're all a multiplicity of 1. They only occur an odd number of times. Even does not alternate, odd does. We are looking for the negatives, so we want this area and this area. -3, open, because it's not equal to, union 1 to 3. Number 6 also factors by grouping. On this one, though, we get a binomial that would give us an imaginary solution, because this would be x squared equals -1. So can't put that on the number line. It's always positive. So only -3 goes in the number line. If we plug in 0, which is up here, I see it's going to end up being positive. Remember, this is the same as this, so I can plug it in there. And so it's going to alternate, negative and positive. I'm looking for the negatives because it's a less than. So it's this area. It was a closed dot this time because it was equal to. Negative infinity to negative 3, closed. And then the last one, number 7, you're going to want to remember it has to equal 0 first. So first thing you need to do is subtract that 12x squared. Pull out the GCF is x squared, and you get this quadratic, which does factor nicely to x plus 6x minus 2. Then we're going to put all those on the number line. This is a root at x equals 0, but it has an even multiplicity. It has a multiplicity of 2. It occurs twice because that's squared there. So we'll start that 0, will not alternate around there. My other roots are negative 6 and 2. So don't want to plug in 0 because that was a root. So I'm going to plug in something big like 10. If I plug in 10, I can see a positive times a positive times a positive. That gives me this positive. Alternates, does not alternate around the even multiplicity, and then alternates again. Always plug in numbers in those intervals to check and make sure these are right. If you get your plus and minuses wrong, there's no way to get your answer right. So be careful, double check and make sure you're getting those correct. And then we wanted less than. These were all closed because it was equal to. And the less than, we're really looking at this. Is this area and this area, which is all of it together because it was closed dots there, negative 6 to 2. Excellent. Go practice.